So, I don't know, you guys all know me. My name is Segun, and I'm the Solar Business Development Manager for Transform Nigeria Limited. So today, we want to talk about steps to excellent solar installation. All right, steps to excellent solar installation. I titled this because of some reasons and some observations that we have seen over the past few months that we've been doing some installation across different locations and for different clients. So the title of this topic is very, very important. So steps to excellent solar installation. So first, at the end of this training, essentially I just wrote this down that what we are looking at is at the end of the training, we should be able to go back. Each one of us should be able to go back, especially those of us that are on the field, and those of us also in the office will have one or two things that we can pick from this training. All right, because at the end of the training, we will do like a case study of a sample installation and processes like you said, what to do and all the rest like that. So but we'll focus on the installation proper so that we'll be able to trash out some things that we have observed. It means that when you get to the site, look at the resources in terms of how much of sun can we get in that place. Now there are several tools you can use to do that. Okay. For instance, there's a tool called PW Watts. If you just Google it, PW Watts, it will give you an idea. To take you to a website where you can put the location. So the way God has created the earth, the way the sun starts, from the day, and then in the evening it goes down. So it's not evenly distributed everywhere. Some continents have more sunlight than others. So that's just essentially what we are saying here. However, it's always good to just check it to say, okay, because some clients will really ask you, for instance, there's a client in Port Harcourt that is asking how much energy are they going to generate? How much energy are they going to generate? If you don't have an idea about evaluating the site solar potential, you might not be able to answer that question. So you use tools. I'm a fan of tools. I like tools. I like using things that simplify things for me. That's why I have technology today. So with technology, all of these things are very easy to be done. So you just go to PW Watts, enter your location. In fact, if you have the coordinates of that location, you can enter it there, and then it takes you to another page where you enter what is the solar power that you want to install there. So at the end of the day, you look at, okay, I want to do maybe a 2000 kilowatts and 2000 watts peak solar. So you enter 2 kilowatts peak inside on that page. Once you enter that figure and you click next, it will calculate the energy resource that you will get from that particular location for 1 year, for every month. So you can look at what that data does is you can tell the customer that in June the energy you'll be getting might not be much, because especially in Nigeria, in June we have what? Rainy season. So you have less of that. So that's that about the site assessment. Then the second point is very, very important. Design the solar system layout based on the assessment. Now, when you go for assessment, I've continued to emphasize this. It's very important that you keep all of these things I'm going to mention now in perspective. Number one, you need to engage the client. Understand what the client wants. Because for you to install a system excellently, the customer have to be happy at the end of the day. Am I correct? So all those activities that you are doing, you carry panel, you do person, you give him quotation, you do everything, you do the site assessment. At the end of the day, the customer is not happy. Do you understand? Your installation is not excellent. So for it to be excellent, you have to do a design based on what the customer wants. And so that's why that number one point I mentioned now is engage the customer to understand what the customer wants. And please, when we say engage the customer, don't shy away from any questions. I don't know what I'm talking about. Don't shy, ask all the hard questions, even if it's, I don't know if it is on the call. Ask all the hard questions. Some people say, I don't want to ask him about how much is his budget, or ask all the hard questions, because at the end of the day, if the customer is not satisfied, it might be as a reason of, it might be because maybe you didn't engage the customer properly. So the customer is saying, I want to carry fridge, I want to carry AC, I want to carry pumping machine. Can you pay for it? Give him an idea, especially when you have the idea. Give him an idea. Look, all this thing you want to carry now, if you want to do it, give him the Naira Kobo figure. When he hears the Naira, he will shift back and say, is it that expensive? You tell him yes, because so it's important that you have that engagement with the client. Now, the second point I'm going to quickly mention is the site layout. This is where you do it. This time, so this when you get to the site and you are doing an assessment, in fact, you should have a sketch of this is where the panels will be. This is where my breaker will be. This is where my batteries will be. This is where the inverter will be. You should have a sketch. So in our site assessment reports going forward, we should have sketches of whatever site we go to visit. And those sketches, you will have engaged with the client. Okay, hello sir, please, where do you want us to put the battery? Where do you want us to put the panel? Even though you are the one that will advise them on the panels. Because the panels too, you have to look at the orientation. There's what they call azimuth, there's what they call orientation. There's what you call where the panel will face, where it can get more resources. Mostly, your panel should face the south. Your panel should always face the south, because during the early morning, that's where it comes from the east, but your panel should face the south. Okay? So, you have that decision to make to tell them. However, you should also engage the client to say, okay, we are putting the panels on the roof. It's not that place that we're going to put the panel. Let have that engagement. The batteries, this is where we want to put the batteries. Are you okay with it? Because if you don't have that engagement, and another thing that we have observed is sometimes the person that will decide where those equipment might not be around. You need to find a way to engage them for residential installation. For commercial installation, of course, it's a different ballgame. But for residential installation that we're talking about, this is it. So we should ask all the questions so that there won't be ambiguity. The client will not be saying, no, you didn't tell me, I didn't know about it. When did we agree? And all the rest like that. So please, let's do the design properly at that initial stage of the assessment to highlight all the areas that we are going to use in that particular facility. So the next thing is equipment procurement. Why did I put this? I included this because, of course, you know, in BaseCom, before we do any procurement, it has to pass through PMO. Okay? I'm sure all of us know that. It has to pass through PMO. There has to be a what we call PID, project information document. There has to be a PID. There has to be a budget cost sheet. There has to be a material request. So all of these things are under this equipment procurement. Why I have also highlighted this step as also very important is the engineers that on the field that will do the installation. You need to check the equipment that procurement is giving to you. So Other solar panels, inverters, and mounting hardware. Ensure equipment meets quality standards. So ensure that what procurement is giving to you is number one, quality standard. Number two, it can deliver what you want to do. So this rests upon the shoulder of the installer on site. You have every right to say what you are giving to me will not work. Okay? You have a right to say what you are giving to me will not work. I will share an example that happened here also. So sometimes procurement will say, okay, we want to help you save money, instead of you to use 450 watt panel, we got 500 watts for you. But if you didn't have that engagement with them, to say, look, it's 450 watts I have here. Make sure you get 450 watts. By the time they bring 500 watts, you might discover that 500 watts might not be able to work for you at the end of the day. So that is where this comes in. Equipment procurement is very important. So you have to work hand in hand with procurement. We'll come tomorrow. So please, this rests on the shoulder of the what's it called? The installer. Make sure that you engage. Procurement also discuss with the installer to confirm exactly what they want before you commit to buying. So that you don't now buy, you now have to go and replace and all the rest. Okay, so preparation and approval. This is also important. So you prepare as you are going for the schedule installation, obtain necessary approval and permits. So some sites you might need approval, you might need permission. So it's not when you now take the the equipment to the site, you now get it, they now tell you that, okay, you didn't tell us that you are coming now. So how do we didn't plan for you today. So all the fuel that you bought to go there is gone. So it's all aside that also. This is indirectly linked to assessment, preparation. What do you need to do the installation? Do you need ladder? Do you need resources? You need to prepare and communicate that ahead. It's not on the day you are going for the installation, you now say, I remember, I will need labor. You should have known from the day of the assessment. So you plan for it. If you need, what's it called? So from that day that you're going to do the inspection, you'll have looked, okay, if I'm going to do the installation, what do I need? So you have to be proactive, you have to think about the future ahead, and also including, and look, this installation will be hard. If the office now not provide, it's a different thing again. But just make sure you highlight it. Do you understand? Make sure you highlight it. So that's preparation and approval. Then installation proper. Now coming to the installation, this is where I'm going to focus on after I show you all the steps, for us to see one or two things on how to decide breaker, cable size, and some other things. So installation, install solar panels on the roof or ground mounted. Like I said earlier, there's always a position for your solar panels. You should be facing the south. Check. Always facing the south when you are doing it. Some solar panels are, they design them and it has automatic rotation. So as the sun is moving, it's also moving. So those are different. There are different types of installation. However, most of the installation we'll be doing will be just normal static installation. It doesn't have to move. So we always face it to the south. Maximize the places where you can get sun better. Now connect panels with wiring and inverter. We'll show you that in the case study that we have. So how to connect the panels, connect the inverters and all the rest. This is the stage. Ensure proper grounding and safety measures. So that's the safety that I'm talking about. So what I've discovered is, now grounding is different from such what's it called? Arrestor, lightning arrestor. Now, what most residential homes do is they will install lightning arrestor. The lightning arrestor also goes to the ground. If you understand that installation, it goes to the ground. You have a rod that is buried in the ground. They will now mix it with the what's it called? Because they don't want to spend money. They will now mix their grounding in the house with that of the lightning arrestor. It's wrong. It's supposed to be separate. So every house is supposed to have a separate grounding bar that is connected to the house. So if you go for inspection, you should find out, okay, do you have grounding in your house? Where is it? Show us. These are all part of the things that should make up your what? Site inspection. You ask, do you have grounding in your house? Because if they don't have, if you want to do an excellent installation, then you should provide for that grounding. So that's that the installation. But we'll still talk about this electrical connections, all right, and testing. So this is also very important. That's why I think we might do that. Connect the solar system to the main electrical panel. Conduct system testing to verify functionality. So all the electrical parts in the system, you need to test. Okay, you need to test. You need to be sure that they are bringing out the right voltage. Now, so coming to this is directly linked to you also. You as the person doing the quotation, even the installer. Look at the specification of the inverter, specification of the panel. So testing is very important. You need your multimeter to do the testing. Test the battery voltage. Test the AC output, test the AC input, all right, test what other test? Read from neutral to positive. Are they reading to each other? Something could be making them to read. Maybe the cable is compromised, all right. All those tests, you need to carry them out. You test from neutral to what's called positive to see that they are not reading to themselves. So those are some of the tests that you conduct as you complete the connections. We'll talk about the connections, like I said. Yes. So after you've done electrical connection and testing, you now come and do integration and commissioning. Okay? So remember, you have done assessment. You have engaged the client. The client must have told you, hey, I want to power this, I want to power that. Now, for most residential installation that we have been doing, there's what we call separation. I can also say it's integration and commissioning. So separation is, in a house, you have what we call distribution box. Do we know what distribution boxes are? So I'm sure most of us know. Now, in that distribution box, you have all the equipment or appliances in the house, socket outlet, lighting point, everything within the house connected in that distribution box. You have to now separate it, because most houses, they didn't plan that they are going to have inverter or have solar. If not, the ideal thing to do is to have a separate distribution box that is for solar, so that your outputs from your inverter, negative and positive, is just going to that what distribution box, so that you don't have to do any separation. They've already separated what they want to power. But that's not the case. In most houses, what you have is that you have a distribution box. Now, should I do the separation, or should I leave it for an electrician? I'm speaking this in terms of practically now. The system is not completely off-grid, especially residential. So when we say off-grid, it means that there's no, all they depend on is just battery completely. But this one, most installation is not completely off-grid. It's off-grid in a sense, but they have to use their grid to also back it up. So all of these points are very important to make sure that you integrate them with the system before you configure all necessary functionality on the installation and commission the system. It's very important. An inverter have manual. Please don't throw away the manual. We have seen situations where we have installed and a system that is supposed to be configured as lead acid, we'll leave it as user defined. You might not understand what I'm saying, but what I'm saying is In the inverter itself, there's what they call functionalities and options that you can choose by pressing the buttons on the inverter. So make sure you configure the inverter according to what the manual says. If the manual say the default value of the input voltage, for instance, the default value is 76 volts, for instance, and you get to that input on the screen, you get that, you now see a figure. They now put 76, they now put 89, example. Change it to 76, because that's the default that they put. If you leave it at that 96, the system will not function properly. So anytime the input voltage is less than 96, the system will not work properly. It will not charge properly. So leave it at the default values that they have said. But the one that you know specifically, for instance, when they tell you select your battery type. So your battery type, you should select what the battery type you are installing. If it's lithium-ion battery, select it there, that lithium. You will see it there, except that inverter doesn't have it. If it's tubular batteries is represented by flooded. You see the right FLD on it, right FLD during when you are configuring it. So you select that. So that's talking about configuring all functionality or the installation and then commission the system. All these steps are very important. So we should avoid saying, okay, you have installed the inverter, you've connected the battery, you know, you've done all your connection, and you switch on back. Oh, there's light now, everything is working. No, you have not finished. Go to the inverter, check all the functionality, configuration, defaults. Make sure they are set properly and you save it. Then you are finished, and that means you are finished and you have commissioned that system. That's how it should be done. So client orientation, orientate the client, teach the client how to use the system. Who is at home always that will be seeing the system? Talk to the person, explain. It's over. This one is 100% important. Explain to the client. Don't go and on your AC on the inverter, or don't go and call electrician to come and say, hey, this is not working, come and put it for me. So explain to them what the system can power, how to use it during the day, during the night. Explain to them. For example, now in Capsco, 1.5 kVA, somebody is putting freezer on 1.5 kVA. How? It will not last. 1.5 kVA with one battery, 2 panels. Do you understand the point now? So you have to explain to them, because most people will say, I have solar in my house now. No, plug the fridge now, it will work. It will work, but your battery will drain very fast, because you're just using one battery. Because on that one battery, you plug your light, you plug your fan, you on your television. Now you have to put fridge again. So explain to the client, train the client how to use the system, and then show them that there's also maintenance. If you have tubular batteries, they should call from time to time. So Basecom, we always have 1 year free maintenance. They can call us, we'll go there, look at it, and do some cleaning for them. So that's that about the client orientation, and then documentation, handover, and post-election support. All of this is very important. You have to document, sign out properly with the client. Once you have done all of this, make sure the client signs out. No excuses. Say, no, come back next week, come back next month. Alright, share documents and share the manual. Please give them the manual. Don't keep it. Don't say they cannot use it. Don't give it to them. It's their property. Give them the manual. But tell them, before you go and press anything, if you don't know, call us. Don't just go and start pressing because you have manual. That's part of the orientation that you should do. It's your responsibility, the engineer on site, on ground, to do that. If the person that will be operating the system is not on ground, call the person, discuss with the person, tell him this is how this thing is done. We have finished the work. This is how it's being used. This is how you use it. This is how you use it. This is how you use it. Explain to them. Don't just leave and say, they will understand. They will know. Like, they will not understand. Though. They will not understand. So provide comprehensive handover package to the client. So JCC and all the rest. Offer ongoing support and maintenance. Be available. Schedule follow-up visit. So schedule follow-up visit also. From time to time, visit the clients. Go there. Because that is where you can get referral. When you visit him without the person knowing, just say, madam, I have come to check this your system. Is everything working? Everything is okay? No, it's okay, everything is okay. Madam, you don't have any other person now. Hey, yes, so that's true. There's this my neighbor that says, you can get another referral. But if you don't even visit at all, there's no way. The person will not be using the system and enjoy. So that's that. And then I think that's the end. Case study, install a 4,600 watts hybrid inverter with 2,700 watts solar panel and 4 numbers 220 amps, 12 volts, 12 volts battery. So I'm going to call Ayo. I said I'm going to surprise you to tell us how are you going to do this installation. Quickly, just explain. Just tell us how you are going to do this installation.
From the presentation, Mr. Segun actually said, he made mention of something. He said, first of all, we need to get the specification of the solar panel, the inverter, so that we will know how we are going to connect them. Maybe the inverter will be able to accommodate the solar panel. So in this case, so are we assuming that the
assume anything?
Okay. So install a 4,600 watts hybrid inverter system with and 4 batteries. 12. Okay. Now the question here is, I'm trying to understand it. It's just to install. If we're installing,
and tell us the process. What and what to do.
Okay, what and what we need to do.
What you do, okay. How are you going to connect it?
Yes, how are we going to connect it? Okay, I'm going to get my inverter, the breakers, surge breaker, the input breaker, the output breaker, the PV breaker too, everything. Then my panels. So my panels goes to the surge breaker. From the surge breaker, there's also a PV breaker too. So from that PV breaker, it goes to the inverter. So from that, I connect my battery to also have a breaker too. From that breaker, from my battery to the breaker, then from that breaker, it goes into the inverter. So to the inverter, from the inverter, there's an input session, there's also an output session. So from the output session, it goes to my changeover. So there's also input coming from the DP. So that input coming from the DP also goes to my changeover too. So on that changeover, there are 3 points. The input, that input is either grid or generator. There's output from your inverter, and there's one that goes to your load. What do I mean by load? Loads are the things that you want to be powered on that inverter. So that changeover is just for you to switch either to inverter, the output of the inverter, or to switch to, maybe you want to use grid, just only grid. I hope I'm not missing anything. Okay.
So that's the step. Thank you, Ayo. So that's the step. Let me show you what he has just said now. Now, when you are doing solar installation, there are some things that are very important that you need to consider. Those things have caused us serious issues in the past. So we have an understanding of what it takes to install a system excellently, starting from site inspection and all those things that we've mentioned.